In this video, we will find out how are the TF reference frames generated and where they are located with respect to the different objects we will have in our environment, including our robots. First, let's understand how are the TF reference frames generated. The TF reference frames are generated and updated by the ROS package Robot State Publisher. This package uses two sources of information to generate and keep track of reference frames. The first one is information regarding the movable joints on the joint states topic. The second one is the robot_description parameter that is populated from the URDF or Zacro files. Additionally, the Robot State Publisher also uses the root link of the Zacro file as the fixed frame of reference. Typically, the world link that we saw in week 2 is used as a fixed frame of reference, but this can also be different when we have robots that move around, like in our case with the TurtleBot. Further, it is our responsibility as users to arrange for the information required by the Robot State Publisher package. Let's first see how the joint state information can be arranged for. In the code files provided to you for this week, you can find this snippet in the hrwros_environment.launch file. We use the joint state publisher ROS node to combine the joint state information from the two robot arms. Note that the TurtleBot directly publishes on the joint states topic via the corresponding Gazebo plugin. So, we just have to ensure the joint state information of the two robot arms are also published onto that topic. On a side note, recall from week 1 that multiple nodes can publish to the same topic. Here is one instance. We have the Gazebo plugin for TurtleBot publishing to the /joint_states topic, and we will see now how the joint state publisher will also publish to the joint states topic. This is achieved via the source_list parameter. As you can see, the robot1 joint states and robot2 joint states are elements of the list of topics that contain joint state information, and joint state publisher will publish the combined information onto the joint states topic. Just as a quick check, let's use the ROS topic info command to inspect the joint states topic. We can see that there are two publishers as expected, Gazebo publishing joint state information related to the TurtleBot, and the joint state publisher publishing joint state information about the two robot arms. Also, we can see that robots_state_publisher node is subscribing to the joint states topic. Remember, this is a node to utilize the functionality provided by the Robot State Publisher package. Hence, the S is added to distinguish the node name from the package name, and also the fact that this node is publishing all the reference frames for our factory simulation, which involves 3 robots. And naturally, the move group node from week 4 is certainly using the joint states for keeping track of the movement of the two robot arms. Now, the second source of information, the robot_description parameter, which is populated from the Zacro files we made in week 2. We again look at a snippet from the hrwros_environment.launch file, where we load the URDF onto the parameter server via the load_hrwros.launch file. And in the load_hrwros.launch file, we have the parameter robot_description that gets updated with the URDF elements via the hrwros.zacro file. Recall also from week 2 that URDF basically defines your environment geometry. In other words, we use URDF to define where different objects in our environment are located with respect to each other. Alright, now that we know how the reference frames are created within ROS, let's find out where they get defined. I mean, we saw these reference frames, right, and also the objects, but how did we know that the reference frames should be placed where they are? Why not like this? That should also be okay, right? So, where can we find this information then? Remember week 2 again? When you first added the box geometry for the pedestal, it was at an incorrect location and stuck halfway in the floor? and the origin tag of the joint element was modified to move the pedestal to the correct location. This origin tag is what defines where the TF frames are placed. Recall that TF helps us to maintain and inspect relative information between objects in our world, and objects are defined via links, and links are connected to each other via joints. That's why the TF frames are defined at joint origins, so that we know how two links are located relative to each other. Great. Let's actually see these TF frames in the context of our factory scene to understand these concepts better. See you soon in the next video.